Section 3.3 Density. In this section we are going to begin looking at how we define density and then how we calculate density. Density is really just the ratio of mass to volume of a sample of anything. So really it's how heavy something is for how big it is. Lead is very dense. You can have a very small sample of lead and it's very, very heavy. Where air is very, very low density, you can have a very large sample of air and it weighs very, very little. So this is the equation that we use for density, mass over volume. V points down, so the V is always on the bottom of this equation. Density is typically in grams per liter or grams per milliliter. Remember back from first semester that a milliliter is equal to centimeters cubed. Okay, so those two things are the same. Mass is typically in grams. It can be in kilograms, but typically we don't do that. And again, our volume, like we said, is in liters or milliliters. So as you look at your mass, you can see that the label for mass is going to be on the top of the density label, and the liter for volume, or excuse me, the label for volume is going to be at the bottom of your density label. Okay, you're not going to cancel out those units because they're two different units, and so those will stay as your unit for density. So, solving a problem. These are the steps that you should use. You should always write down what you're looking for, and in this case, density is what we're looking for. We know from this question over here, what is density, that's what we're trying to find. Of a sample with a mass of 2.50 grams, so we would write our mass down. And a volume of 1.7 milliliters, so we would write that down. Now we know every variable in this equation, and so now all we have to do is take our mass and plug it in here on the top, and our volume and plug it in here at the bottom, which would look like this. Again, you can see that these two labels are not going to cancel out. You take 2.05 and divide it by 1.7 to get our answer of 1.5. The next thing you have to do is look at your significant figures. Right here we've got 1.7, that's two significant figures. Right here we've got 2.50 with three significant figures, so you pick the least amount. We want 2 in our final answer. If we were going to solve for mass, so in this case it says what is the mass, so we know that's what we're solving for. Of a 2.34 milliliter sample, it has a label of milliliters, so we know that that's going to be the volume. And it says a sample with a density of 2.78 grams per milliliter. So again, it tells us its density, but we also see this label of grams per milliliter, so we know that is density. So again, we know 2 out of the 3 variables. We'd plug our density in here and our volume in here, and then we would solve for our mass. So you take your density, you multiply it times your volume, because we want volume to cancel out, and then we're going to solve for our mass. So we set it up with our 2 variables in there. We would multiply each side by our 2.34. They cancel on the right. Our labels cancel on the left. And we end up with 2.34 times 2.78 is 6.51 grams. 3 significant figures in this number, 3 in this number, so we round our answer to 3 significant figures here. Third example, we're going to be solving for volume. So here it says a sample is 45.4 grams. We know that's our mass. Has a density of 0.87 grams per milliliter, so we know that's our density. Again, looking at labels, we know this is mass, even if they don't tell us that, and this is density because of the grams per milliliter. We're going to solve for the volume. So again, we look at our equation, we plug in our density this time and our mass. Now we're going to have to solve for volume. To solve for volume, it has to be on the top of your equation, so we multiply each side by volume. It cancels out on this side, and so we get volume is times 0.87 grams, just like right here, grams per milliliter, and then that's equal to 45.4. So to solve for V, we would have to divide this side by our density, and then also the other side by our density. This side they cancel out on the left. The right hand side, our labels of grams cancel out. You would take 45.4 divided by 0.87 milliliters, and we would end up with our volume being 52 milliliters because there are two significant figures in this number here, the 8 and the 7. Graphing density, we use slope, so rise over run. Rise is going to be how far you go up, run is going to be how far you go over, so y2 minus y1 over x2 minus x1. So the y is going to be the mass and the x is going to be the volume, just like it shows over here on this graph. So the slope is mass over volume, and if you look at that, that's exactly what density is mass over volume. So the slope is equal to density. So if we can figure out our rise going this direction over our run going across, we can figure out the density of a substance. So when does an object float? It's going to float when it's less dense than the substance that it's in. So if this is water here at the bottom, you can see the particles here are closer together than whatever is floating on top, which could be oil. So oil is less dense than water, and it's really all about how close the particles are to each other. So if we know the density of water is 1.0 grams per milliliter, or grams per centimeter cubed, we know that something less than that density will float in water. Okay, so the top again, fewer particles, same space, so they're less dense than the ones on the bottom. Okay, so let's do one more problem to decide if something is going to float in water. If a 22.7 gram sample, so grams tell us this is going to be our mass, has a volume of 47.8 milliliters. Again, it tells us volume, but we also see milliliters, so we know that's our volume. Will it float in water? Well, we have to figure out the density to determine that. So we use our density equation, plugging in our mass and our volume. We do our division. We want 3 significant figures because there's 3 significant figures here and 3 significant figures here. And we get that in grams per milliliter because these are 2 different labels, so they do not cancel out. If our density is 0.475, that's less than 1, and so this object should float. Second example here, what volume is this sample? That is 27.5 grams, so again that's our mass, and it has a density of 3.5 grams per milliliter. So we're going to be solving for our volume. Plug in our density here, our mass on top, and so again we have to multiply each side by volume to get volume on the top of the fraction. So we have volume times density is equal to mass. Divide by our 3.5, so it cancels out on this side. We divide here, and our volume is equal to 27.5 divided by 3.5. Our grams will cancel out for our labels, and we'll end up dividing 27.5 by 3.5, 3 significant figures here, 3 on the top, 2 on the bottom. So we only want 2 on our answer, and we get 7.9 milliliters. So I think that's enough practice with our density equations that you should